It is said that a 50-gram ball is thrown from a window with an initial velocity of 8 meters per second at an angle of 30 degrees above the horizontal. Using energy methods, we have to determine the kinetic energy of the ball at the top of its flight and its speed when it is 3 meters below the window. So the scenario is something like this. Maybe this is a window, and let's just assume this is the window, and this is thrown upwards from the window. It goes there and then comes down, and there are two positions where we have to find few things. Find actually just one thing here. The kinetic energy, which is top position. This drawing is incorrect, but let's just assume this is the flight and this is the top position. So this is where we need to find, let's call this is position A, this is position B, this is position 3, like that, and this is 3 meters below the window where is point C. At B we have to find the kinetic energy, and at C we have to find the speed. The only information we have is the initial velocity and angle, that is 30 degrees, and we have to use energy method. That's important. So what I shall do when it's thrown here, let's first do the kinetic energy at the top. So when it reaches the top, it doesn't have any more the vertical component of the velocity, that becomes 0. It does have only the horizontal component. Here the horizontal component is 8 cos 30 degree and vertical component is 8 sin 30 degree. This is at point A, where it is, from where it is thrown. At point B, what happens is its vertical component, of course it will be something else, but I mean the vertical component keeps changing, but at point B it is 0 because that's the maximum point where the vertical component becomes 0. However, the horizontal component stays the same throughout the flight. We know that. So we know that there is only one component of the velocity, actually only one, the velocity is basically horizontal with the ground, horizontal. It's 0 degree with the ground basically. So the first, the initial velocity is horizontal component stays the same throughout. So when it is at position B, the kinetic energy will be, of course, let's say KE is equal to half mvb square. M doesn't change, of course. So VB, and now VB is 8 cos theta, which is only the horizontal component, because vertical component is 0, so that comprises of the full velocity, because vertical component is 0. So this one becomes half into 50 over 1000 because that's in gram, and this one is just 8 cosine of theta 30 degree. So half, I will write again, 50 over 1000 into 8 cosine of 30 degree, and once I calculate this I get cosine of 30 degree whole square, of course, sorry, because mv square. So once I do that I get 1200 joules or 1.2 kilojoules. So that's the kinetic energy at the top. Now the second part is what's the speed when it is at 7. To find that, what we can notice is at position A it has a kinetic energy, and that will be just half mva square, and va is 8, we know that at position A. So at position A the kinetic energy is half mva square, and va is 8, which is the initial velocity, and it also has a potential energy with respect to position C, because position C is 3 meters below. So compared to position C, it doesn't have to be the bottom point, just we have to find what is position A's, when the ball is at position A, what is its potential energy with respect to point C, and that will be, of course, mgh if we say, So the total mechanical energy will be, this is the kinetic energy, and the potential energy will be mg, let's say, I don't know, HAC maybe. Now HAC is 3 meters, and this is meter per second. So we know the total mechanical energy is like that. Now because there is no other loss, the total mechanical energy will stay constant throughout. Of course, there won't be any change of mechanical energy. So we have to find what is the velocity at point C. So the potential energy at point C with respect to point C will be, of course, 0, because the height is 0. What the potential energy we have written here for position A is that with respect to position C. So with respect to position C, the potential energy is of course 0, because it is at the same height. So that part is 0. Kinetic energy will be half mvc square, and potential energy will be 0. Because the mechanical energy will stay constant, we can equate these two energies. This is the total mechanical energy at position C. And this is total mechanical energy at position A. So I hope that is making sense, because the total mechanical energy will stay the same throughout the flight, because there is no other loss, there is no other air drag or any kind of friction. So we can equate these two, and from that we know everything. Actually, if we notice, we know VA, because that's 8, HSC we know, and of course M we know, VG, M is given. So what I shall do is, I can write here half M, which is 50,000 times VC square, is equal to half into M, 50 over 1000. So I am writing the right hand side first, and then plus M 1000 times 9.8 times 3, because that is the height from A to C. We are just writing the potential energy of A with respect to position C. So once I solve that, what I get VC to be is 11.08 meter per second. So that is the velocity at position A. So we have solved this problem using only energy concept. We have considered only energy basically, mechanical energy, that's potential and kinetic energy.